All right, so today we're going to talk about the difference between reflexive symmetry and rotational symmetry. Okay, so reflexive symmetry is when you can draw a line of reflection and it'll be the mirror image on both sides. So for example, we could take this square. I'm going to draw kind of a dotted line. My pen is not working, but there you go. If I thought of this as a mirror, this dotted line as a mirror, you could see that it would be the same on this side and this side. The other way you could think of it is if you're not really seeing the mirror image, you could imagine folding it along that dotted line. So if I took this same image, this square, and I folded it along that dotted line, notice how both of the sides line up perfectly. In math, we call that it maps onto itself. So anytime you hear the word maps onto itself, it means that it lines up perfectly. So this is a line of symmetry, which means that this has reflexive symmetry. All right, and in this square, there's actually 4 lines of symmetry. You have the horizontal, the vertical, and then you have the 2 diagonals. All right, let's look at the pentagon. We're going to ask ourselves, is there reflexive symmetry for this pentagon? In other words, can I fold this pentagon somewhere to where it'll map back onto itself? And the answer is yes. You could fold it here. Let's go ahead and show you that. So if we fold it right down that vertical spot, notice both sides map onto each other. They both lay flat. So that is a line of symmetry. So this does have reflexive symmetry. And actually, anytime you have a regular polygon, and remember, regular means all the side lengths are equal and all the interior angles are equal. If you have a regular polygon, then your lines of symmetry will equal the amount of sides you have. So since this is a regular pentagon with 5 sides, I know there's going to be 5 lines of symmetry. So I'll go ahead and draw those for you. You could fold along any of those 5 lines and it would map back onto itself. All right, here we have a regular octagon, so without even trying to draw the lines, I already know that there's 8 lines of symmetry. Okay. Over here, this is not a regular polygon. This is a heart shape. But I think you can still see that it does have reflexive symmetry, because if you fold it right there along the middle of the heart, both sides are going to lie flat, or they're going to map onto each other. Okay, so that's reflexive symmetry. It's when you can draw a line of symmetry and it'll reflect onto itself. The next one is called rotational symmetry. And this one is a little bit harder for some students to see. What we're looking for in rotational symmetry is we're trying to see if we can ever take this square and rotate it or turn it and have it line up perfectly again before we make a full 360 degree rotation. So I hope you can see this one does have rotational symmetry. I'm even going to draw a little squiggle line right here so that I know that this is, I'm going to start with that little dotted line on the top. If I rotate it a quarter turn, or 90 degrees, notice that little dotted line is now on the side, but the figure still maps onto itself. I could rotate it again, a quarter turn or 90 degrees, and again it has rotational symmetry. It maps back onto itself. And I could do another quarter turn or another 90 degrees, and it maps onto itself. So this figure does have rotational symmetry. If you wanted to figure out the angle of rotation, this has 4 sides. Anytime you have a full rotation, think about making all the way around a circle or rotating all the way around. That's 360 degrees. So to figure out the angle of rotation, you would take a full rotation, which is 360 degrees, and you would divide it by how many sides it has. This works for regular polygons. I should have mentioned that. So 360 divided by 4, that would be 90 degrees. That means every 90 degree turn is going to map the figure back onto itself, which we just showed you. Every 90 degrees, it lies back on top of itself. So this has rotational symmetry at 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, let's check out our pentagon. Our pentagon has 5 sides. It is a regular polygon. So we can go ahead and take our little mathematical shortcut. Since a full rotation is 360 degrees, we can divide that by how many sides we have. And 360 divided by 5 is 72 degrees. So 72 degrees is the least amount that I could rotate it to map it back onto itself. So sometimes it asks for the smallest angle of rotation. Notice here if I turn it 72 degrees, it would map back onto itself. So 72 is the least, but every multiple of 72 would map it back onto itself. Alright, let's look at the octagon. Alright, I think we can tell that it does have rotational symmetry because you can rotate it and it would lie back on top of itself. So then we would just do the math to figure out what the degrees would be. So again, a full rotation is 360 degrees. Divide that by how many sides there are. And that tells us that our little musical interlude there. That tells us that our rotational symmetry happens every 45 degrees. All right, so that's the least amount, but every 45 degrees it maps back onto itself. So 45 or 90 and so on and so on. Okay, the last one we have is the heart. Remember, we're trying to figure out how far it takes us to rotate it until it maps back onto itself. And if you notice with the heart, you have to rotate it all the way around, right? You can't rotate it a quarter turn and let it map onto itself. It just doesn't work. Can't rotate it 180 degrees. It doesn't work. Can't rotate it any amount until you get all the way back to 360. Y'all, every single object in the world has rotational symmetry of 360 degrees, right? For example, if I take these scissors and I rotate them all the way around, then they're going to be the same, right? So if it only has rotational symmetry at 360 degrees, we say that it doesn't have rotational symmetry. It has to have something less than 360 to be said that it has rotational symmetry. So for this one, if it asks, does it have rotational symmetry? You would say no. If it said, what is the angle of rotation? The only option is 360 degrees. So that one does not have rotational symmetry. I hope this helps.